Now that we've seen exponential functions, let's think about the inverse of an exponential function. These functions are one-to-one, so an inverse must exist. But how can we describe it? I'd like to consider the function y equals 2 to the power of x. One way we could approach this is by making a table of values. We could say when x equals 0, 2 to the power of 0 equals 1. When x equals 1, 2 to the first is equal to 2. When x equals 2, we get y equals 4, and so on. We could put a couple of negative values in here. When x equals negative 1, 2 to the negative 1 is 1/2. And when x equals negative 2, 2 to the negative 2 is 1/4. So we already know in general that to express the inverse, or to find the inverse, we need to reverse the x and y values. So the inverse is a function that will contain these points: 1, 0, 2, 1, 4, 2, 8, 3, 1/2, negative 1, and so on. If we show those points on a graph, that looks like the reflection of the graph of 2 to the x across the diagonal line y equals x. So I could even graph some of these new points that we've found. 1, 0 is right here, 2, 1 is right here, and so on. We will get a picture that looks like this. And yet we still haven't expressed this with an equation. We could go a step further and we could say if you just reverse x and y values, the expression x equals 2 to the power of y represents this equation. And yet we want to rearrange this so that we can express y by itself as the dependent variable depending on x. In order to do this, we need to talk about logarithms. So a logarithmic function is what we have just sketched and what we have just shown in our table of values. And it takes the form y equals log base b of x. That is equivalent to saying b to the power of y equals x, which is what I wrote here, how I expressed the inverse of this exponential function. Y equals log base b of x is our standard form and is our way to write it in terms of x. I always try to remember here that the log form and the exponential form of an equation are related in this order. When we are saying y equals log b of x, that is the same thing as saying b to the power of y equals x. I should be able to move back and forth between those two expressions of the equation. And in fact, it is often the exponential form that allows me to evaluate the logarithmic form. We'll look at that in a future video. One thing we've learned about inverse functions is that the domain and the range are switched from the original function. So you will recall that an exponential function has a domain and range. The domain is all real numbers, and the range is from 0 to infinity. So our inverse function, y equals log base 2 of x, as we now know how to express it, has a domain of 0 to infinity and a range of all real numbers. The exponential function had a horizontal asymptote at y equals 0. The inverse function, log base 2 of x, has a vertical asymptote at x equals 0. All of the properties between x and y are interchanged. So in general, we need to remember that the domain of logarithmic functions is from 0 to infinity. The range is all real numbers. The log of a non-positive number is not a real number. So I cannot express, for example, log base 3 of negative 1. That is not real because its exponential form, 3 to the power of something, will never equal negative 1. It will always result in a positive number. I cannot take the logarithm of a negative or a 0 number. One final set of definitions. Two common logs that we often speak about are the common logarithm and the natural logarithm. We frequently work with these two logarithms. We often work with base 10 in science, and we do this so frequently that it has become its own notation. Y equals log x is understood as log base 10, even though the base is not supplied. Remember, this is the same thing as saying 10 to the power of y equals x. A natural logarithm is a log with base e. We've seen the natural number e show up already in exponential functions, and we need to know how to take its inverse, or how to express its inverse, as a logarithm. And we write this as ln of x, natural log of x. This is the same thing as saying e to the power of y equals x.